Let's solve for another example, but this time let's tabulate our data for us to have a more organized solution. So in this, we would once again be dividing this into components and into distinguishable shapes. So for the first part, I want it to be this rectangle right here. So this one, so let's say that this is to be area 1. So for our area 1 right here, area 1, and that is to be the rectangle. So I would be erasing this. And for our area 2, and I think I want my area 2 to be this one right here. So this triangle right here. So let's say that this is to be area 2. So for our area 2, that is to be the triangle. And for our area 3, so we have this semicircle right here. So let's say that that is to be our area 3. So area 3 and semicircle. Okay, so if you can remember a while back, so we have solved for our bar x and bar y using this moment formula right here, wherein we have solved for the moment of these areas right here. Okay, so for the area of the first part, so for this rectangle right here, that is to be 100 by 225 mm. So solving for that, 100 times 225, that is to be 22,500. So 22,500. So this, all of these are in millimeters squared. Okay, and for area 2, I want it to be this. So this triangle right here. So area 2 is to be the area of this triangle right here. But if you can see, so though we would be having this altitude right here, so this is to be h, and the base of the triangle is not determined yet. So we only have these dimensions right here. So let's solve for the rest of the base of the triangle. So kulang nga tayo, no? Ito yung ating triangle. So this one. And we don't have this dimension here yet. So for us to solve for that dimension, so take note that the radius of this semicircle right here is to be 75 mm. So meaning this is also 75 mm and this is also 75 mm. So the diameter of this semicircle right here is to be 150 mm, since 75 times 2 is equal to 150. So 75 and 75. So erasing that, that is actually equal to 150. So if that is to be 150, and this rectangle right here has a dimension of 100 by 225, so meaning this dimension right here is also 100 mm. So this whole, so this whole dimension right here is also equal to 100 mm. So if that is to be 100 mm and this is already 50 mm, so it is safe to say that from this dimension right here, from this side right here up to this side right here, that is to be 50 mm. So erasing this, so if that is to be 50 mm, so 50 mm, and if the whole diameter of this semicircle right here is to be 150, then it is safe to say that this dimension right here is equal to 100 mm. So erasing this for us to have a neat workspace. So if that is to be 75 mm, this is to be 50 mm, then this is to be 100 mm. So now we have the dimensions of our triangle already. So for the area of the triangle, so that is to be so area triangle, and that is to be equal to 225. So this is to be the altitude, and our base is equal to 100 plus 125, and 100 plus 125 is equal to 225 also. So 225. So the area of a triangle is 1/2 base times height, so I would be dividing this by 2. So 225 times 225 divided by 2, that is to be equal to 25312.5. So 253 312.5. So I would be erasing this dot right here. Okay. And for this area right here, I mean for this semicircle right here, so the area for the semicircle is half of the circle. And the area of a circle is equal to pi r squared. And for the area of the semicircle, we would be dividing this by 2. So from that, pi r squared divided by 2 is equal to pi times 75 mm squared divided by 2. So our area of the semicircle is equal to pi times 75 squared divided by 2. So that is to be equal to 8835.73. So 8835.73 mm squared. So that is to be for the area of this one right here. Okay, so next up, we would be getting the centroids of these areas right here along the x-axis and along the y-axis. So along the x-axis first, if we are to determine the centroid of this rectangle right here, so it would be just half the dimensions. And for bar x, so if this is to be bar x right here, bar x is equal to 100 divided by 2. So this is to be 50 mm. So 50. And as for the bar y of this rectangle right here, it would be half of the depth, which is 225 divided by 2. So meaning that these dimensions right here is to be 225 by 2. I mean that coordinate right there is equal to 225 by 2. So that is to be 112.5. So 112.5. So 112.5. And I would be erasing this. So next up, let's solve for the centroid of the triangle. It would be this one right here. So this is to be bar x. And this is to be bar y. So for your bar x, so if we are to get its centroid from this point right here, so this dimension right here, so if you can see here, so this dimension right here is 1/3 of this dimension right here, which is 225. So 1/3 of 225. But for our x, by the way, this shouldn't be bar x, so that is to be x2. So for our x sub 2, our x sub 2 is equal to 100 mm. So 100 mm plus 1/3 of 225. So why is that the case? Because for the center of this triangle right here, so I will just be erasing this, because 1/3 of this triangle right here is this. This is to be 1/3 of the triangle. I mean the base of the triangle. So 1/3, 225, plus this dimension right here. Since our x2 should be in reference with this axis right here. So from that, our x2, x sub 2 is now equal to, so 100 plus 225 divided by 3, and that is equal to 175. So 175 mm. So our x for A2 is to be 175 mm. And as for the bar y, so erasing this, our bar y for this particular triangle right here, so in this triangle right here, if this is to be the centroid of this triangle, so assuming that it is here, this is also 1/3 of this dimension right here, which is also 225. So for y2, 1/3 225, and that is to be equal to, so 225 divided by 3, so that is to be 75 mm. So our y here would be 75. And for our A3, so our A3 would be this semicircle right here. So for the value of x, if we would be basing the centroid using this one right here, so that is to be 4/3 r divided by pi. So for bar y, so this location right here, so for y, that is to be 4/3 r divided by pi. And from that, our y is equal to 4/3, substituting known values, and the radius here is to be 75 mm divided by pi. So solving for y, that is equal to 4 times 75 divided by 3 divided by pi. So our answer here would be 31.83. So that is to be for y. Okay, and for our x, so if this is to be the centroid of your, what you call that? If this is to be the centroid of your semicircle, this dimension right here, I mean this length right here, is to be 50 mm plus the radius of 75 mm. So 50 plus 75 is 125. So now that we have all of these values already, what we would be doing is that we would be multiplying the area times the respective lever arms. So the area times the lever arms would be 22500 times 50. So that is to be for the first. So 1,125,000. And for here, area times y, that is to be area times y. So 225 times 112.5, so that is to be 253, 1250. So 253, 1250. 281241. So 281,241.28, let's say 29. But take note, guys, that this area right here, so for area 3, this should be negative. So ultimately, this one is also negative. So negative, negative. Why is it negative? Because we would be removing this one right here. Because we are solving just for the centroid of the shaded area right here. So the area of this semicircle right here should be negative. Okay, so after that, we would be getting the total area of all the figure right here. So if we would be getting the summation of these areas right here, we would be getting the total area of this shaded area on the top. From that, 22500 plus 25312.5 minus 8835.73. So that is equal to 38976.77. So 38976.77. Okay, so for the summation of the product of area times x, so that is to be 1,125,000 plus 687.5 minus 1104466.25. So our answer here would be equal to 445,0221.25. So that is for the summation of the product of area and x. And as for the summation of the product of area and y, that is to be 253,1250 plus 189,8437.5 minus 281,241.29. So our answer here would be equal to 414,846.21. Okay, so why did I get these summations right here? Because if you can remember in our previous example, for us to get the value for bar x, we would be getting the moments of the areas. And if we would be simplifying this equation right here, it would be like this. So bar x times the total area, so the moment of the total area, is equal to the summation of all the areas. So meaning So summation of the moments of all the areas, I should say. So area times lever arm, so times x. And if we are to get the value of bar y, so bar y times area total, that is to be the summation of area and y. So it would be like that. And for us to get the value of bar x, if we are only concerned with bar x, that is to be bar x is equal to summation of area times x divided by the total area. The total area is to be equal to this value right here, and the summation of the products of the area is to be these values right here. So substituting known values for us to get the location of bar x, I mean the location of the centroid along the x-axis, that is to be 445,022,1.25. So it would be this value right here divided by their total area, which is this. So 38976.77. So solving it with our calculator, that is to be 445,022,1.25 divided by 38976.77. So our answer for bar x is equal to 114.18 mm. So meaning, along this axis right here, the centroid of our figure is located approximately here. If this is to be equal to 114.81. So to avoid confusion, I would be moving this first downwards. So it would be here first. So let's now solve for bar y. So using the same formula as with this, so instead of getting the summation of moments, I mean summation of the product of area and x, for bar y, we are to get the summation of the products of area and y divided by the total area, so 80. So bar y is now equal to, so what is the summation of area and y? So that is to be 414,844.6.21 divided by our total area, which is 38976.77. So our answer here would be equal to, so 414,844.6.21 divided by 38976.77. So our answer here is equal to 106.43 mm. So meaning our centroid for this particular figure is located somewhere here. It would approximately be here, provided that that is to be 106.43. So once again, moving this very line right here. So this is to be the location of your centroid, which is in this part right here. Our centroid, so I will be deleting this. So the coordinates of your centroid is that of 114.81, 106.43. So this is to be the centroid.